So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
Most people remain unconvinced by Tesla Bot Optimus robot, despite Elon Musk's bold promise of a $20,000 price tag, and insists manufacturing each unit costs only $10,000. Beyond the headline price, in the most recent update video, Tesla Bot Optimus demonstrated an impressive array of household chores, all driven by a single unified neural network. It effortlessly tossed trash into a bin, swept the floor with both a broom and a vacuum, tore off a sheet of paper towel, stirred food in a pot, opened a kitchen cabinet, and drew the curtains closed. The highlight, when Optimus picked up a fore-link component from a Model X and carefully placed it onto a wheeled dolly for transport and even sweep factory floors, tasks that could save or earn users thousands annually. Yet many observers still view Gen 3 as overhyped and question its real-world utility. Humanoid robotics presents far greater AI and engineering challenges than assembling cars, so skeptics wonder whether Tesla can deliver on both performance and affordability. Welcome to Tesla Car World. How affordable is Tesla Bot Gen 3 really? Let's talk about value, you see. When most people hear the word price, they immediately brace for impact. But what if I told you that Tesla is flipping that narrative? Elon Musk has shared more than once, 3 times in fact, that the Optimus humanoid robot is expected to come in between $20,000 and $30,000. That's Tesla setting the tone for what affordability could look like in the age of intelligent robotics. And while the latest chatter from Musk on X pegs a future tag of $60,000 for both Optimus and the Cybercab, here's the catch. It's only possible if Tesla scales. Earlier this year, Elon Musk offered a glimpse into Tesla's near future. By the end of 2025, Optimus, the company's humanoid robot, could be ready for customers. Now, let's not pretend it'll hit the market at rock-bottom prices on day one. Like any breakthrough technology, the early stage carries the weight of R&D, fine-tuning, and ramping up production. So yes, the first few Optimus units could land in the $50,000 to $70,000 range. But here's where it gets interesting. That price tag isn't just a number, it's a doorway. In fact, Tesla's long-term projection for Optimus falls between $20,000 and $30,000 once mass production kicks in. That's less than half the cost of a mid-tier EV today. But more importantly, it's a shift in how we think about labor, efficiency, and return on investment. And while early buyers might pay more upfront, they'll likely be the ones reaping the earliest and largest gains. Why? Because Optimus isn't just a helper. It's a force multiplier. Whether it's assembling components on the factory floor, assisting the elderly at home, or performing physically demanding tasks around the clock, this robot doesn't call in sick, take breaks, or need training every few months. What you're really buying is consistency, performance, and the freedom to redirect your human workforce toward higher value tasks. Elon Musk has made it clear. Gen 1 won't be widely available. Tesla plans to deploy about 1,000 Optimus units inside its own factories first. It's a smart move, refining real-world performance before opening the gates. During this internal phase, Tesla gets the chance to optimize both the robot and the workplace environment it serves in. For customers, this means Gen 3, the model aimed at external buyers, will already be road-tested, refined, and ready. Imagine walking into your favorite electronics store and seeing a sign that reads, Tesla Bot Gen 3, only $30,000. After all, today's humanoid robots routinely set you back well over 6 figures. But that's exactly the rumor Elon Musk let slip during an investor call in June 2025. Gen 3 is poised to crash the market with a price tag roughly equivalent to a used sedan, not a luxury yacht. For those living on fixed pensions, Social Security, or modest retirement savings, $30,000 might still sound steep until you run the numbers on traditional care. Consider a home health aide charging $25 per hour, 2 hours a day, 5 days a week, adds up to over $13,000 a year, and that's before factoring in tip or overtime. In just 3 years, you've watched as much as $40,000 flow out the door, often without any guarantee of consistency if the aide calls in sick or decides to retire again. Contrast that with a one-time purchase of Tesla Bot Gen 3, which requires no weekly scheduling, shows up on time every time, and doesn't ask for a vacation. Over the course of 5 years, even if you tack on a bit for maintenance and electricity, you're still looking at a fraction of the cost of human-powered care. But robots break down, you might protest. Fair point, but remember, Tesla already has a worldwide service network for its cars. If your bot needs a tune-up, it'll waltz itself to the nearest service center, or a technician will collect it. And you won't be stuck with a 10-figure repair bill. To put it into perspective, think of trading in your trusty old sedan for a car that can also cook your morning oatmeal. Well, almost. You wouldn't bat an eye if your clunker stopped working 50 feet from the highway on a snowy day. Rather, you'd be furious. Yet somehow, we accept paying double for human aides whose reliability can't be guaranteed. Gen 3's price tag forces us to rethink that logic. And since you're not exactly renewing a mortgage here, Tesla intends to roll out financing plans tailored to retirees, low or zero interest, longer terms, and perhaps even a trade-in credit for older personal mobility devices like scooters or stair lifts. If that sounds too good to be true, consider that Musk has a track record of lowering prices over time. Look at how Tesla cut the Model 3's entry point from $35,000 to under $30,000 within months. So while we're technically talking numbers, what we're really talking about is access. Tesla isn't trying to sell you a robot. They're offering a future where advanced technology fits into real lives, real budgets, and real homes. And that, my friends, is a conversation worth having. Think big. High-profile individuals and corporations where automation isn't just a nice-to-have, it's a necessity. Names like Amazon, FedEx, and Walmart come to mind. These early adopters won't blink at a $50,000 price point because for them the value is obvious. Operational efficiency, labor cost savings, and let's be honest, prestige. For celebrities, owning Optimus may be as much about convenience as it is about cachet. Imagine a high-profile artist or entrepreneur freeing up time by letting a robot handle errands, scheduling, or simple home tasks. And from Tesla's perspective, every high-visibility placement is free global marketing. You couldn't buy better exposure if you tried. Tesla isn't throwing customers into the deep end. Before Optimus goes on sale, the company plans to roll out a rental program, giving people a chance to see what this technology can really do before making a commitment. We expect the rental cost to fall somewhere between $100 and $500, which is a small price to pay for access to a cutting-edge solution that could soon become indispensable in homes and businesses alike. So, while some might focus on the initial price tag, the real story here is value over time. The early cost is a gateway, not a barrier. And for those who understand how exponential gains work, Optimus could be the best investment they'll make in this decade. How will Tesla's Optimus Gen 3 win over the world's skeptics? It's no secret that many observers still aren't sold on Tesla's humanoid effort, even with Elon Musk insisting a future Optimus will land in the $20,000 to $30,000 range, roughly half the cost of a typical EV. And yet, even after confirming the body's ability to tackle everything from ballet pirouettes to household chores, public enthusiasm remains surprisingly muted. Some critics argue that Optimus Gen 3 doesn't quite match the hype. So, what's behind the hesitation? And how far has Tesla really come? Just as electric cars felt futuristic 10 years ago, Tesla's robots are following a similar arc. Back then, who could have pictured mass EV adoption or governments incentivizing drivers to plug in? Now, Tesla leads the world in EV sales, and its self-driving robotaxi demo recently stole the show, proving their autonomy software is world-class. They could rest on that success, but Musk has bigger plans, turning Tesla into a top-tier, tech powerhouse. After revolutionizing transport, his next frontier is life-sized robotics, hence Optimus. Trusting a humanoid with everyday tasks is a big leap. Unlike cars, where you check specs, test drive, read reviews, buying a $20,000 robot requires faith and a promise. To date, Tesla's teaser reels have shown Optimus folding laundry, stacking blocks, sweeping factory floors, and, most recently, tossing trash into a bin, mixing ingredients in a bowl, and even performing a ballet routine. Impressive? Absolutely. But until customers see these moves executed smoothly in real homes and factories, doubts linger. Tesla's journey with Optimus began in 2021, when the project was first launched. By late 2022, Tesla engineers had their first working prototype on display, marking a critical proof of concept. Just 6 months later, in mid-2023, Optimus Gen 1 rolled out, though only for internal use as Tesla fine-tuned its capabilities on the factory floor. Before the year was out, the company introduced Gen 3, boosting its speed by 30% and equipping it with highly dexterous 22-degree of freedom hands. Today, that same Gen 3 model can perform an impressive array of tasks, dancing ballet steps, loading scrap into bins along the assembly line, measuring and stirring ingredients in a kitchen setting, tending to stationary machinery, and sorting battery cells at production line speeds. And the evolution is far from over. Elon Musk recently hinted on X that a completely redesigned Gen 3, informed by thousands of hours of in-house testing, will arrive by the end of this year. When you shop for a Model Y, you'll scour range tests, interior walkthroughs, harsh weather trials, range comparisons, sometimes hundreds of clips and articles. By contrast, Optimus buyers have only a handful of polished demos. Yes, Tesla quietly deploys about 1,000 Gen 1 units across its gigafactories, where robots weld frames, inspect weld seams, clean conveyor belts, and help load finished parts. That field testing sharpens performance, but it hasn't trickled down to public test drives, or in this case, public test works. Creating a humanoid that can learn complex sequences, such as ballet choreography or the nuanced motion of stirring soup, is a monumental AI and engineering challenge. Unlike software updates over Wi-Fi, each Optimus build still requires hands-on assembly and calibration before it can watch and mimic new motions. Tesla's approach, internal stress tests, incremental gen upgrades, is sound, but what customers crave is on-camera evidence of Optimus carrying a laundry basket upstairs, swiftly sorting parts along a moving line, or fetching mail from the door. Boston Dynamics set the bar high, Atlas flipping, spot navigating rough terrain. Today, Tesla must outshine mere standing demos. It needs to broadcast Optimus smoothly guiding a pallet into a warehouse forklift, or orchestrating a cooking routine in a real kitchen. How safe is the new design of Tesla's Optimus Gen 3? When you cradle your granddaughter, let's say she tips the scales at about 125 pounds, you feel her warmth, hear her laughter, and instinctively gauge her weight so you don't overstretch your arms. Now, imagine a robot built to that exact weight, but it's engineered to lift your laundry, fetch the morning newspaper, and gently help you rise from your favorite armchair. That's the bold promise behind Tesla Bot Gen 3's revolutionary carbon titanium composite frame. By blending the lightness of high-grade bicycle materials with the unyielding strength of aerospace alloys, Tesla's engineers have delivered a machine that tips the scales at just 125.7 pounds, yet can confidently carry well over 149.9 pounds without breaking a sweat. It directly addresses the daily realities of apartment living and fixed incomes. Traditional humanoid caregivers often weigh north of 176.4 pounds, making them about as welcome in a narrow hallway as a runaway shopping cart in a china shop. You may have seen those viral videos of a factory robot taking a dramatic tumble, sending parts and sparks flying. If that happened next to your heirloom china collection, your heart would skip more than a beat. By contrast, Gen 3's low center of gravity and flexible composite shell allow it to glide past doorways and around furniture without the slightest wobble. Of course, lighter weight also means lower energy consumption, a detail that matters deeply when your monthly budget is set in stone. Tesla estimates that Gen 3 sips about 30% less power than its predecessor, meaning that your electric bill won't balloon into "I can't believe it isn't crypto" territory. For retirees living on pensions or modest savings, that efficiency translates into peace of mind. You can use your dishwasher, microwave, and television without worrying that the bot's own charging cycle will tip you into financial discomfort. In practical terms, the slight hum of its lithium-ion batteries is more soothing than any passbook ever printed. Safety, too, is woven into the very fibers of this robot's design. A 57 kilograms frame equipped with collision detection sensors ensures that if it accidentally bumps into your beloved cat, unlike heavy industrial robots which could send small grandchildren sprawling, Gen 3's composite limbs flex under pressure instead of snapping, so there's no risk of metal shards or sudden malfunctions. It's like comparing President Biden's famously endearing, but occasionally shuffling, walk like Biden, stride to a graceful waltz. Both have character, but only one avoids the occasional stumble and keeps the dance floor intact. Picture this. You're in your cozy living room, the afternoon sun filtering through the curtains, as Gen 3 effortlessly unloads the dishwasher, folds your favorite plaid socks, and deposits them neatly in your dresser drawer. Moments later, it glides into your kitchen to prepare a simple omelet, its arms moving with the precision of a seasoned chef. Throughout the day, it navigates tight corners, low-clearance furniture, and the occasional rogue throw rug with the finesse of a ballroom dancer, all while sipping power so conservatively that your electricity cost barely registers. By harnessing a carbon-titanium composite, materials once reserved for jet engines and high-performance cycling frames, Tesla has struck the elusive balance between bulk and brawn. You don't have to rearrange your entire home to accommodate a hulking care machine, yet you gain a helper robust enough to support your mobility needs, from steadying you on the stairs to lifting shopping bags from the car trunk. It's the kind of thoughtful engineering that turns science fiction into everyday reality, without demanding you remortgage your house or sacrifice your beloved armchair. In the grand tapestry of retirement living, where independence and dignity are as precious as health itself, Gen 3's lightweight frame and titanic toughness offer a refreshing promise, a dependable companion that respects your space, your safety, and your budget. No longer must you choose between an oversized mobility aid that dominates your living room and an underpowered gadget that barely clears the floor. With Tesla Bot Gen 3, you finally get a harmonious blend of strength and subtlety. Can polished videos of household chores and factory tasks truly prove Gen 3's worth in everyday life? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. Think you've already seen Tesla's humanoid robot do it all? Hit play on an 8-second clip and you'll understand why the crowd drowns out the machine. Franz von Holzhausen merely gestures, and Optimus Gen 3 strides out unfettered, pivots, snaps a sidekick and settles back to attention. No tether, no guardrails, no audible gear whine. That whispered display is the perfect doorway to the deeper story. Tesla Bot Optimus has shed safety frames, doubled its finger joints, quadrupled hip torque, and lost almost 10 kilos, vaulting past rivals that still hide behind tripods or curtains. Over the next few minutes, we'll unpack how harmonic drives silence it, how a 76 plus 34 centimeter zero-moment footprint keeps it upright, and why its 45 kilograms carbon honeycomb frame is half the mass of Boston Dynamics Atlas. If you thought Optimus was just a demo, the next pages may rearrange your expectations about humanoid labor worldwide. Welcome to Tesla Car World. What are the huge updates of Tesla Bot Gen 3 in this launch? At 8:31 p.m. on June 6, 2025, a silver-black silhouette slipped out from stage left at Summit, Detroit. Franz von Holzhausen raised an eyebrow. Optimus Gen 3 answered with a jaunty wave, then snapped into a clean sidekick that sent its center of mass arcing over one stationary foot. No cables, no counterweights, no safety gantry in sight. The crowd's reaction was half gasp, half whoop. They had just watched 45 kilograms of carbon titanium and silicon balance itself through a perturbation large enough to topple most research bots. That 8-second clip, posted by Jason Raznick and requoted by Nick de Cruz Patane, has now raced past 10 million views precisely because it shows something refreshingly ordinary. A humanoid robot behaving like a confident human on an unprepared stage. So why does no tether matter more than backflips? Human-scale kicks are brutally hard. The torso must yaw 90 degrees. The stance ankle generates greater than or equal to 1.2 grams lateral acceleration, and the robot has roughly 300 milliseconds to shift its inverted pendulum center back over the support polygon or crash. Optimus does it with closed-loop, 1 kHz torque control feeding a predictive model that runs on the same Dojo inference hardware slated for Tesla vehicles. The robot's 125-pound, 57 kilograms mass is spread over a 173 centimeters frame, half the weight of Boston Dynamics' Electric Atlas, so the angular momentum budget is much tighter, yet the kick lands without oscillation. Equally telling is the silence. Every actuator is direct drive harmonic, cutting acoustic output by approximately 15 decibels versus Gen 2. Put bluntly, the kick isn't showboating. It's a stress test that proves Tesla's controller can keep the zero moment point inside a footprint, just 34 plus 76 centimeters wide, while limb dynamics change violently. Rewind to AI Day 2022, when Musk conceded that Optimus's first tentative walk was the first time it operated without a tether. Only minutes earlier, the same prototype had been rolled on stage buckled to a safety frame for diagnostics. 3 years later, the Detroit bot strolls untethered, waves individual fingers, and kicks, all actions that force rapid, whole-body rebalancing. Tesla stripped 12 kilograms of mass, replaced steel with carbon fiber honeycomb, and collapsed its control stack onto a single compute spine. The result is a robot that treats a live stage like factory concrete. Exactly the consistency customers will demand in 2026 pilot programs. When we look back, Boston Dynamics' new all-electric Atlas certainly roams untethered and hauls engine covers with exquisite precision. But at 89 kilograms, it outweighs Gen 3 by almost a factor of 2 and still relies on custom off-board chargers between demos. Aptronic's Apollo hits 72 kilograms and publicly advertises the option to be plugged in or tethered for continuous operation. A pragmatic but literal lifeline that would have been impossible on the Summit stage. Figure AI's Figure 02 pilots at Bayerische Motorenwerke AG show promise yet remain caged behind safety curtains, limited to less than 3 miles per hour walks and bin picking. None of these rivals has broadcast a live kick or comparable perturbation test without at least a safety perimeter, underscoring why that 8-second Detroit clip feels like a watershed rather than a stunt. Freedom of motion is more than optics. It underwrites total cost of ownership. A robot that never needs tether-grade power cabling or overhead fall arrest rigs slashes integration costs by double-digit percentages, especially on retrofits. Tesla layers an even sharper edge. Volume manufacturing. Internal estimates still target a bill of materials cost under $25,000 once production shifts to Giga Texas, whereas analysts peg Apollo at $150,000 to $250,000 and figure at low six figures. Combine that price delta with a lighter chassis, less floor reinforcement, and a controller already amortized across millions of EVs. Competitors may match the trick one day, but Optimus showed the shortest, clearest path from lab novelty to shop floor utility, and it did so with both feet firmly, freely on the ground. How does the new Tesla Bot Gen 3 hand do everything? If you replay Tesla's new demo in slow motion, you'll notice something that only shows up when a robot finally crosses from claw to hand. Optimus doesn't just wave. Each of the 5 fingers fans out, pauses, and then recloses along subtly different arcs, enough to spell out micro-gestures like, "OK," or a beckoning curl. That independence springs from a jump from 11 to 22 degrees of freedom, DOF, per hand, essentially doubling the skeletal joints the controllers can address. Elon Musk confirmed the figure last year, calling it very close to the human 27 degrees of freedom baseline. The effect is instantly visible to lay viewers and a huge deal to grasp planning algorithms, because every extra DOF opens a new axis for force closure on odd-shaped parts. Behind the elegance is an equally radical drivetrain swap. Each finger now runs a frameless torque motor mated directly to a miniature harmonic reducer with an inline torque sensor and absolute encoder. Tesla's actuator bill of materials, leaked through teardown notes, spells it out. Frameless motor plus harmonic reducer plus torque sensor plus position sensor plus bearings. Stack buys Optimus 3 things. Rivals struggled to combine. High reduction, so the fingers lift a 20-pound box one moment. Back drivable softness, so they can cradle an egg the next. And millisecond rate torque feedback the AI can trust. Harmonic gears are also nearly backlash-free, eliminating the click you hear on many lab hands when direction reverses. The jump in finesse shows up in raw numbers. Engineers inside the program quote closing times under 250 milliseconds for a full flex extend cycle, roughly twice as fast as Gen 2, and tip-posing repeatability under 0.3 millimeters, thanks to that sub-milliradian torque loop. Tesla watchers who froze the video frame by frame measured peak thumb abduction of approximately 34 degrees, a range that lets Optimus oppose the thumb to any finger pad, not just to the index as before. Combined with capacitive tactiles on every distal phalanx, the same sensors that let Gen 2 poach an egg without a crack. The new hand crosses the threshold for threading, wiring loom routing, and other factory micro-tasks Musk says are next. Boston Dynamics Atlas still relies on a task-specific 3-finger gripper. According to internal blog posts, the design prioritizes ruggedness and the ability to handle 20 kilograms payloads over fine dexterity, though it does allow for modular fingertip attachments. Meanwhile, Figure A, Eyes, Figure 02, features an impressive 16 degrees of freedom per hand. However, that's still about 1/3 fewer controllable joints than Tesla's Optimus. Early feedback highlights some issues with grasping asymmetrical parts. As for Apptronic, its Apollo robot pairs a commercial ability-style prosthetic hand with a 7-degree of freedom arm. The prosthetic brings sophisticated pressure-sensing capabilities, but with only 5 motorized degrees of freedom. It's limited in performing fingertip regrasps during in-hand manipulation. Altogether, these systems reflect distinct trade-offs between dexterity, durability, sensory feedback, and mechanical complexity. The net result is that Tesla now sits alone in a narrow band of humanoids that offer full 5-finger tendon-based motion and industrial-grade torque feedback. Foxtech Robotics teardown notes that Optimus Gen 3's tendons route through ball-screw linear actuators in the forearm, a layout that keeps heavy motors out of the delicate phalanges while still achieving 22 degrees of freedom kinematics. Add the company's real-time vision stack, inherited from FSD, and you have a manipulator that can pinch grip a washer, palm a half-liter bottle, or post-grasp pivot a 10-kilogram battery pack into a rack. Feats that require both the fine compliance of torque control and the brute stall force of harmonic gearing. How would you use Tesla Bot Gen 3 when it's real? And is it finally time to believe the hype? When people think of humanoid robots, it often sparks one of 2 reactions. Either wide-eyed excitement at the idea of never having to do dishes again, or immediate fear that we're on the verge of living in a sci-fi movie where robots take our jobs or rule the world. Then there's a third group that mostly laughs at humanoid robots, seeing them as clunky machines that wobble around like a confused grandpa, or worse, like Biden stumbling through a speech. And to be honest, Until recently, it was hard to take most of these robots seriously. But something's changed, radically, in just the past 2 years. The progress we're seeing isn't just incremental, it's groundbreaking. Tesla's Optimus Gen 3 in particular has gone from concept to a fully functioning robot that may soon become a common presence in homes and workplaces. Unlike flashy prototypes that vanish after a single demo, Tesla's approach is all about scaling production and integrating robots into the real world, which sets it apart from nearly every other player in the game. At a major Tesla event originally meant to highlight the company's autonomous vehicle, the Cybercab, Optimus unexpectedly stole the show. Dozens of these robots were on display, interacting with guests and showing off their skills. It was no longer just about cool tricks. Tesla was sending a clear message. This robot is being built for real, everyday use. So what can Optimus Gen 3 actually do? A lot more than you might expect. It can inspect packages, fold laundry, water your plants, serve drinks, clean the kitchen, charge your Tesla, and even play games or dance with your kids. It responds to voice, touch, and, crucially, gestures, allowing for communication even when words aren't available. Elon Musk confirmed this at the event, noting,
Yeah, you'll be able to customize the personality, customize the voice, and really kind of the robot will kind of get to know you as well and know your preferences. You won't even have to say things because it'll just kind of understand you.
What powers all this is Tesla's unique advantage, real-world AI. The intelligence that allows Tesla cars to drive themselves is now being adapted into a humanoid form. As Musk put it,
and Tesla has some important missing ingredients that others don't have, which is our robot has a real brain. It's like the Wizard of Oz, Tin Man.
this brain doesn't just react, it learns. Optimus can watch a video and then replicate the task, whether it's preparing a meal or mimicking a dance. The implications are massive. You won't need to manually program tasks anymore. Just show it once, and it learns.
Where it can watch a video of something like a person and then learn just by looking at that video and do that task.
Of course, Optimus isn't perfect yet. Like any new technology, there are bugs. Musk openly admitted that early versions will have their quirks, maybe a robot that brings you an empty plate when you ask for food, or fumbles slightly on stairs. But with Tesla's proven track record of rapid iteration, like scaling Cybertruck production from a few hundred to 3,000 units per week in less than a year, it's hard not to believe they'll work out the kinks quickly. And the fact that the robot is already correcting its own mistakes, like reorganizing spilled parts autonomously, shows just how far the tech has come. What also makes Optimus Gen 3 so different is its physical design, especially its hands. Elon Musk noted that nearly half the engineering work went into getting the hands right, not just for strength, but for dexterity and human-like precision. Previous versions had only 11 degrees of freedom in the arms and hands combined. The new model doubles that to 22, allowing it to perform much more delicate and complex tasks. Most competitor robots use simple claw-style grippers or 2- or 3-fingered designs. But Tesla is pushing for human-level dexterity, 5 fingers, realistic joint movement, and even differences in finger length that mirror our own hands. Why? Because, as Musk said, this level of control allows Optimus to not only pick up heavy boxes, but also handle small, fragile items like a wine glass or a pen. That opens up its potential use, not just in households, but also in elder care, manufacturing, and even surgeries or lab work in the future. Tesla is also bringing the scale. While most companies build humanoid robots one at a time, Tesla is already planning a rollout of 5,000 robots in the first production wave. Musk said Tesla hopes to scale that up dramatically. If that actually happens, and yes, Musk's timelines can be optimistic, Tesla could be shipping 1 million robots a year by 2027. That would make humanoid robots not just a novelty for billionaires, but an accessible product for average households and businesses. Pricing is also key. Musk noted that you should be able to buy an Optimus for between $20,000 to $30,000, putting it in the same range as a new car. For families, small businesses, and even schools, this means that owning a humanoid robot might not be a futuristic fantasy, but a real option within just a few years. With all of this positions Tesla not just as a car company, but as a robotics company on the verge of transforming the labor market. The potential isn't limited to domestic chores. Imagine robots working in warehouses, assisting in hospitals, or performing repetitive tasks on assembly lines. They could reduce labor costs, increase safety, and free up humans for more creative and fulfilling work. That's why Elon Musk believes Optimus could be the most valuable product Tesla will ever create. In his own words, that number may seem outrageous, but the vision is clear. While the EV market is getting crowded, there's virtually no competition in the consumer-grade humanoid robot space. If Tesla can deliver on its promise, Optimus may become as common as smartphones or laptops in the future. In short, Tesla Bot Gen 3 isn't just another robot with cool moves. It's a high-functioning AI-powered assistant that learns from humans, adapts to their needs, and evolves through experience. Be honest, after seeing that untethered kick and smooth hand gestures, do you finally believe Optimus is more than just a flashy prototype? Or are you still waiting for real-world proof? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos.
Be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000, fundamentally at scale, the Optimus robot, you should be able to buy an Optimus robot for, I think, probably $20,000 to $30,000 long term.
The miracle is not that a bipedal machine can lift boxes or pour coffee. Boston Dynamics did circus tricks years ago. The miracle is that Tesla aims to do it at a sticker price comparable to a mid-grade sedan. Why does cost matter? Because usefulness is a function of prevalence. An expensive showpiece is a party trick. A $20,000 appliance is an economic force. Will affordable $20,000 robots revolutionize economies or truly become expensive paperweights prized only by elites? Welcome to Tesla Car World. So, how is Tesla Bot Gen 3 a breakthrough in AI? To hit that price point, Tesla leans on the muscle it has already built in Fremont, Shanghai, Berlin, Austin, and now Mexico. The Optimus actuators, control boards, sensors, and, crucially, the 4680 cells ride the same supply chain superhighway that feeds Model Y production. Every penny shaved off a battery tab weld or drive unit casting echoes inside the robot's bill of materials. In pure manufacturing calculus, Optimus is a derivative of Tesla's existing empire, not a standalone moonshot. Inside the husk of Optimus Gen 3 lies a roughly 3 kilowatt-hour 4680 pack. 5 times the volumetric energy density of the old 2170 format allows engineers to bury power in the torso instead of strapping a brick to the robot's back like a jetpack. The result, 22 pounds shed in a single revision, down to 138 pounds all in. Less weight means smaller motors, lower thermal load, cheaper structural members, and efficiency cascade. When Tesla rolled out the first Optimus prototype on AI Day 2022, the robot could barely shuffle across a stage. Fast forward to May 2025 and the third-generation machine tells a radically different story. It now plucks a tennis ball out of midair, executes a synchronized dance routine, and threads a sewing needle, all on video streams released by Tesla in the space of 6 months. At the heart of that leap sits a brand new end effector, a 22 degree of freedom hand that doubles the articulation of Gen 2, 11 DOF, and closes to within 18% of the human hand's 27 mobile axes. Engineer Milan Kovac, who leads the manipulator team, disclosed that each finger is driven by cable and tendon and paired with touch sensors capable of resolving forces under 1 Newton, a configuration that lifts pinch precision from 5 millimeters to 1.4 millimeters, according to Tesla's internal benchmarking. Real-world footage supports the specifications. In the ball catch clip, November 2024, the robot tracks a fluorescent tennis ball traveling at approximately 11 meters per second, about 40 kilometers per hour, and grabs it in 380 milliseconds, with no visible signs of remote control. By May 13, 2025, a second video from Tesla's Austin lab showed two Generation 3 units executing a 32-beat shuffle step in sync. Hips, knees, and ankles remaining within plus or minus 1 degree of the intended path throughout the 47-second recording, a tolerance usually associated with motion capture puppets, rather than free balancing bipeds. Independent roboticists have noted that Boston Dynamics' Atlas still clears bigger jumps, but Optimus now claims the most articulated production hand in the industry. The jump in coordination is inseparable from an equally aggressive software overhaul. Tesla abandoned classical joint space control in favor of a vision-first stack ported from its full self-driving program. A deep dive explains that Optimus now operates using a streamlined version of the photon-to-control pipeline. 8 global shutter cameras provide input to a transformer-based neural network running on Tesla's full self-driving system on chip, generating 100 Hz volumetric scene graphs. These are then integrated into a model predictive controller that operates at 500 Hz. Latency from image frame to torque command is down to 23 milliseconds, roughly half the figure disclosed for Gen 2 last year. Even more significant is what happens between demos. On May 29, 2025, the Optimus X account posted a clip of the robot folding t-shirts after simply watching 45 minutes of first-person GoPro footage, a switch from teleoperated imitation learning to video-only self-supervision that Tesla says slashes human teaching time by 70%. Beneath the outer shell, Gen 3 is both lighter and more enduring. A teardown shared with interesting engineering estimates the frame weight at 125 pounds, 57 kilograms, driven by 40 electromechanical actuators and powered by a 2.3 kilowatt-hour structural spine battery. This enables the robot to operate through an 8-hour mixed task shift or 4.5 hours of continuous walking at 5 miles per hour. Power consumption at idles around 100 watts and peaks near 500 watts when carrying a 45-pound payload. Figures that place the robot's energy cost of transport below 2 joules per kilogram per meter, already within the broad efficiency range of adult humans. These metrics translate into tangible improvements in capability. Pinch force increases from 8 newtons to 24 newtons, enabling the robot to pick up a raw egg without breaking it, or tighten a 6mm bolt to the specified torque on Tesla's 4680 battery production line. Cycle-to-cycle repeatability in a 3-point pick-and-place task, tested over 1,000 repetitions, shows positional drift limited to 0.6 millimeters. Comparable to mid-range SCARA robotic arms that cost as much as the entire robot. The upgraded proprioceptive system, featuring 6-axis inertial measurement units in every limb segment, feeds into a reflex loop fast enough to withstand a 15-kilogram lateral shove. Logs from the Austin demo show center of pressure recovery in 620 milliseconds, with a maximum ankle deflection of 4.3 degrees. By integrating sensing, actuation, and control on a common FSD-grade silicon substrate, Optimus Gen 3 achieves a level of whole-body compliance that begins to look less like scripted robotics and more like biological motor control. Taken together, the 22 degrees of freedom hand, sub-30 millisecond vision loop, and full-shift battery endurance are redefining what a PUBR general purpose truly means in the realm of humanoid robots. Where Gen 1 merely waved, Gen 3 assembles wiring harnesses, stock shelves, and performs solder reflow, tasks that demand human-level finger finesse, not just locomotion. The result is a platform inching toward the threshold at which robots stop being novelties and start filling genuine labor gaps, both on Earth and, if Elon Musk's Mars timetable survives, on other worlds.
This is a super big deal. Like my prediction is that, on this front, is that Optimus will be the biggest product of all time by far. Nothing will even be close. I think it'll be 10 times bigger than the next biggest product ever made.
Mention the term humanoid robot, and many of us, myself included, can't help but envision a sleek, high-tech future where machines effortlessly take over the laborious, risky, or simply tedious tasks we'd rather avoid. Imagine a household assistant that whips up dinner, scrubs the dishes, and handles every mundane responsibility. Tempting, isn't it? Yet, alongside that optimistic vision lies a more anxious narrative. A growing number of people express unease, fearing that such advancements could displace human workers, or even lead to a dystopian scenario where machines dominate us, echoing the plot lines of countless science fiction thrillers. Of course, not everyone sees humanoid robots as the future. For many, they're still little more than awkward, clunky machines, expensive bundles of sensors and wires that can barely stay upright. Some compare their gait to a confused partygoer at 2 a.m., or even poke fun with political jabs. Honestly, the criticism isn't entirely off base. A lot of these robots still struggle to demonstrate real-world usefulness, and it's no surprise that skepticism runs high. But here's the thing, something noticeable has shifted. In just the past couple of years, progress hasn't been incremental, it's been dramatic. We're not just seeing refinements, we're witnessing a leap forward. Not long ago, the spotlight was mostly on Tesla's Optimus and Boston Dynamics' Atlas. Now, it's a full-blown global competition with companies across continents, from the US to China, racing to redefine what humanoid robots can be. To be clear, this isn't about declaring Tesla the undisputed leader in robotic innovation. But if we're talking about meaningful impact, robots that could genuinely transform everyday life, Optimus might just be the one to watch. With a straight face on CNBC last week, Elon Musk repeated a figure that has now become the fulcrum of every discussion about Optimus Gen 3, under $20,000. Musk says that once the Fremont pilot line clears a cadence of 1 million units a year, total bill of materials plus overhead should fall to about $10,000, leaving Tesla free to sell each humanoid for roughly the cost of a used Corolla while still pocketing automotive-class margins. By comparison, a 6-axis Fanuc M20 industrial arm with less than half Optimus's reach retails near $45,000 before end-of-arm tooling, and Hyundai-owned Boston Dynamics still quotes mid-six-figure leases for Atlas. Price alone, therefore, explains why Morgan Stanley's robotics desk values the addressable humanoid market at $5 trillion by 2050, with Tesla the early cost leader. The repercussions of that sticker shock were immediate. When Tesla opened a non-binding reservation portal on May 17th, the form collected 5,000 corporate expressions of interest in the first 72 hours, according to a live walkthrough filmed at Giga, Texas, and later confirmed by staff email to reservation holders. Logistics giant GXO booked 750 units for third-shift palletizing. German grocer Rui asked for 300 to pilot shelf restocking, and Thailand's Bumrungrad Medical Center reserved 120 for nighttime linen runs, 3 sectors with diametrically different wage structures agreeing on one thing. At $20,000, the payback period on a single-shift deployment falls well below 14 months even before tax incentives. Tesla's own internal math is starker. A robot running 2 8-hour shifts in Austin at $18 per labor hour yields an annual EBITDA of $90,000 against $2,000 in electricity, implying the robot repays itself in about 10 weeks and then compounds cash like a rental property with no roof to leak. Crucially, demand is not being throttled by production capacity forever. In January, the company disclosed that its first dedicated humanoid line is already cycling 1,000 units per month, with a second line under construction that scales to 10,000 units monthly by the fourth quarter 2025. 2 months later, an all-hands meeting leaked to Teslarati quoted Musk daring engineers to build a Legion, 5,000 fully assembled bots, before New Year's Eve, and to stock parts for 10 Legions in 2026. Wall Street took the hint, During the first quarter earnings call on April 22nd, Musk told analysts he is comfortable forecasting 1 million units a year by 2029, 4 years ahead of an earlier 2030 target. That trajectory, if met, would make Optimus the fastest ramping hardware product in consumer history, 10 times quicker than the Model 3 and nearly on pace with iPhone's early growth curve. Yet volume alone does not account for the breadth of the order book. Business Insider's roundup of Musk's spring media blitz notes that Tesla has already earmarked thousands of bots for in-house use before outside deliveries begin, effectively turning the gigafactories into 24/7 showrooms where every visitor can watch a robot do value-adding work. Analysts see that dog food strategy as a demand accelerator. Each Optimus that spots welds a battery tray in Austin or shuttles a kitted tote in Berlin serves as a 5'8" salesman wearing no tie. Add the fact that Tesla plans to lease robots at $3,000 down and $2 per operating hour, a figure buried in a Wall Street analyst note that circulated after the Texas demo, and even smaller firms can de-risk adoption by matching payments to direct productivity gains. Behind the scenes, the economics are reinforced by Tesla's well-worn playbook of vertical integration. The same 48-volt powertrain architecture harvested from the refreshed Model 3 slashes inverter costs, while standardized actuators, fabricated on idle gigapress capacity, drive down unit CapEx per joint. Meanwhile, Dojo's wafer-scale accelerators, amortized over the still-growing FSD fleet, handle motion planning inference at 23 milliseconds, end-to-end, meaning Tesla can bundle lifetime cloud compute inside the $20,000 headline price instead of charging a monthly fee. No rival can yet match that subsidy because no rival owns the silicon, the battery cells, and the factory floor. Taken together, the under $20,000 target upends every spreadsheet in industrial automation, and the near-instantaneous flood of reservations hints at a backlog that could dwarf early Model S waitlists. Whether Tesla hits the ramp is a separate operational question, but on unit economics and visible demand, the numbers already clear the bar. If Optimus Gen 3 truly lands at car money prices while delivering round-the-clock labor, the robot risks becoming not merely Tesla's next big product, but the standard labor commodity of late 2020 capitalism. The first time in history the price of a humanoid drops below the annual wage of the human it is designed to replace. The Mars window that opens in late 2026 has become the organizing clock for everything SpaceX does, and Optimus Gen 3 has just been written into the countdown. Speaking from the Starbase launch site on May 30, 2025, Elon Musk said, "The first uncrewed starship to the Red Planet will fly in that window, with a simulated crew consisting of one or more Tesla-built humanoid robots, rating the schedule a cautious 50 and 50, but insisting the attempt will go ahead even after the 9th Starship test ended in a loss of vehicle 2 days earlier, which retains 80% of its capacity at -20 degrees Celsius." According to the Universe Space Tech brief, the Mars variant adds a multi-layer Kevlar polyamide skin for micrometeoroid grit and swaps the glass fiber covers for aerogel-lined carbon panels that keep core electronics above 5 degrees Celsius without the use of heaters. The first tasks are brutally practical. Deploy rollout solar wings, trench cable runs, anchor Starlink Phase 2 dishes, and stack regolith Lego bricks into 2-meter berms that have surface radiation and block 90% of dust-lift wind. Musk believes a squad of 30 robots working 2 8-hour shifts could raise a 100-kilowatt power station and berm a 1,000 square meter landing pad in approximately 90 Martian solar days, shaving a whole launch window off the timeline for crew arrival. So can a $20,000 robot truly survive Mars better than trained astronauts? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.